Hey, welcome to my another tutorial. So this one we continue to the part drawing. Last video it was doing this assembly drawing and also the exploded view drawing, part trace and etc. So today we are going to continue to the making all of the individual part here on the list here. So in order to do that, so we can create the okay, so we are going to start to create a new sheet. On the place view here there is a command new sheet. Just click here. Okay, so and then we look for the base view. So for example, I want to select my base view. The base view would be the part, of course. So this one, I think, yeah, I'm going to choose this one, part base bar. Wait a minute. Yeah, I think this one is the correct one. Oh yeah, this one is the correct one. So and then just click open, and then of course the Inventor will show the front view first. And for example, if this front view, I want to make it on the right position here. Okay, then the scale, you can adjust the scale and then adjust the identifier and also all the setting. For example, this one, if you want to see the hidden line remove or hidden line show. So in this case, I want to create the hidden line remove in order to simplify the complexity. And the model display option, there is a thread picture. If you like to see the thread picture, then check mark this one, and also the tangent edges. I usually use the tangent edges for the fillets and also for shorten, and then justify at the center. Okay, I think it's all done here, the settings. Okay, all this necessary setting is done. Then I will just click OK. Okay, so this one is the first base view. Okay, so for example, this sheet here is size of right click here to see the size. Okay, so I can edit the sheet. Right now it's at A3. So for example, if I want to make it one part at 1 pages, so I just create this to be A4 format and then just click OK. Okay, so this will be there. Okay, so for example, this base view is on the form of one A4 format. Okay, then I want to add the additional projected view. Okay, for example, this one, I click for the projected view here, like so. Then right click, create. Okay, so and then if I want to make it the section view, I just click here, section view, and then from where do you want to make it the section from, and then for example to the half full section, right here, click here, and then right click, continue. Okay, so this one will be the section B, and then so we can change to the method. Okay, I just click here. Okay, so this one, the B, this one is the identifier for the section view. Okay, then if I want to add the for example the detail view, so I just click here, detail view, and then I click the view, and then I just make it the circle, and then put it probably in the here. Okay, so this one is the detail for the C. Okay, and then if I want to make another projection view from here, just click here, projected, and then click the parent view here, and then you just click on the right side. Okay, and then click create. So the sequence is for the view. I suggest that you create all the necessary views first, and also the sections view, or also the accelerator view or detail view, and etc. Then you can move to the second method, which is the annotate here. So when you click the annotate, is inside here there is a dimension and notes, text, and also symbols, and also all the necessary like this one is for the center line and also for the sketch and publish and etc. Okay, for example here I want to add the center line here. Just click here and then we click the center line here. Okay, so they will automatically create the center line here, here. Okay, so for example I want to add these two here as with the center line. Okay, use that one for the center line, and you still can edit the length of the center line. For example here you can just click the node and then drag it out. Okay, like that. Maybe it's too far away. Okay, yeah, that one and this one for the center line. Okay, so I can drag it like that. Okay, and then as well as here, don't forget to put all the necessary center line. Okay, this one as well, don't forget to put it. Okay, and put it the length. Yeah, I think the necessary center line is okay. Then after you finish with the center line, okay, make sure there is nothing left behind for the center line. Then you can move forward to the usually the dimension. Okay, there is a one dimension here, which is we can create multiple type of the dimension. For example, let's say I'm going to create a dimension for the center to center distance here. Okay, just click there and then click OK. And then, for example, I want to create a dimension from here and then to here. Okay, and I want to make using the chain dimension. So I'm going to create the chain dimension. Then I click this particular, sorry, going to chain dimension. So here and here and here. Wait, let me read it. Here and here and here. Right click, continue. Okay. So this one basically is creating the chain dimension. Okay. So for example, I want to delete this, then going to create a change from here to here and then here and then here. Right click, continue, then they will automatically create the dimension. And please mention that if you drag your mouse and then at some particular point of distance, they will snap. Okay, so this one is the default snap for the Inventor placement for the dimension. Okay, in order to create a very neat and good looking dimension placement, I suggest that you can follow the snap order here. Just click here and then they will create this one, the dimension with the chain dimension. Okay, and also if I want to create another dimension, for example this one for the radius. Okay, so for the radius you just click the radius here. Okay, then click OK, and then for example I want to create the baseline dimension from here to here to here and also to here. Right click and continue. Okay, so they will move to the baseline dimension. Okay, just click on the position, right click and done. So take a note here, there is for example this one is 8 and this one is 15.09. Why this 09 is shown? Because they are using the two decimal places of this decimal, two number behind the comma. Okay, so for example if you want to get rid of this 0.9, double click. Okay, and then precision tolerance. Okay, so the primary tolerance and also the secondary. So if I'm going to put this as a secondary with the one number behind the comma, then you just make it like that. So the model value will be 15.1. Okay, so like this, 15.1. Okay, So probably this one I also want to use the 7.1 as well. Yeah. Okay. And also for the chamfer, if you want to create a chamfer node, just click that one and then click the chamfer node here, right click, okay. Oh, is it the chamfer? I don't think that's a chamfer. Okay, let me here and here. Okay. So the method is just click the chamfer and then click this particular line and also the chamfer. Oh, sorry, the chamfer should be first. This one, chamfer, and then with the reference of this chamfer. For example, the chamfer reference from this one, just right click, okay. So this one will be 3 times 45 degrees, okay. So that's for the chamfer. And for the hole, so if you create the hole with the hole feature in the Inventor, so they can create automatically hole and thread feature, just like that. And then we just put it here, okay. Right click and okay. So this standard hole is for the ISO standard, like we used to. Okay, so this is the diameter indicator 5.5 through. It's mean that the 5.5 through hole. So this particular circle is the through hole 5.5, and also this one is the symbol for the counter bore, which is have the 10 diameter counter bore here, and also the depth of the counter bore is 5. Okay. So yeah, so you can just continue to the particular dimension here until all the necessary dimension will be fulfilled. And for example, if here, then please note that if you create the dimension, then you stay focused on the one view. For example, if I want to create the angle here, this one and this one, then they will show the angle, okay. And also if I want to measure, for example, this chamfer is already done, then this one probably this line to this line, okay. Yeah, this one 45, okay. Yeah. And the particular center point, okay, so the center point will be this one and this one, okay. So center point, please take a note that this not preferable because the dimension you cannot cross each other, so you can click and then handle this one first. Okay, just click and drag and then put it there. And also this one is not preferable like this, so you need to move a little bit to the left, okay, until they are not too close for that one. So I want to adjust the position, okay, adjust the position. Yeah, I think this one stays in here, okay. Yeah, I think it's enough, okay. So walk through to all the necessary dimension, and if you want to create the surface symbol like this, click here, and then for example, I want to show that from this particular face here, okay. Then yeah, I think I'm going to put outside here. Then let me. Yeah, I think I'm going to put this side. Okay, right click, continue. Then they will create this texture symbol. So for example, I want to have this machine, then I will put the specification of the process. This one, the A will be the first requirement of the roughness. So for example, the roughness would be 1.6 like that. And then this one is for the sorry, RA would be 1.6 for example, and with this material removal required. Okay, and then this one, if you want to make a machining allowance, you just type in key inside there, and this one for the machining material removal method, the direction, and this one for the third requirement, so ABC, AB, and this one is C. So probably I'm going to using the method milling like this. Okay, okay. So this particular uh, surface here, okay, as well as the surface over there, probably you can add another surface roughness like this. Okay, this one is for the surface lightness. So for example, for the tolerance, yeah, for example, for the tolerance, so if I want to create the dimension here like this, so okay, 5.3, okay, then if you want to add the tolerance, then you just double click here, and then there is a precision and tolerance. So in here you can choose what kind of the tolerance method that you want to add here. For example, if I want to use like deviation, right? So the deviation would be wait, let me choose. There is so many option that you can choose from here to represent this tolerance. For example, if you want to create the limits and fits, okay, for the tolerance, then you can choose whatever that you like and require. So if here usually if we are using the ISO standard, then there will be creating the edge, the tolerance here, edge, and this is the type of the tolerance, and 7 is the quality of the tolerance, and as well as this one is the limit size. So 5.31 is the highest or the largest diameter, and 5.30 is the smallest diameter for this particular tolerance for the H7. And it's probably the quality I will decrease a little bit. It's 8, or maybe I want to use the tolerance with another tolerance like G6. Okay, so this is the primary tolerance. You can add whatever you want to create, adding this kind of this value, comma value here. Okay, so this one is a hole. Then Inventor will automatically recognize there is a hole. Then the letter here should be the capital letter. Okay, and also if you change this kind of a tolerance, then they also will change the limits here. So this one is easier for us, for the designer or engineer. We don't have to look for the table, for the ISO table for the tolerance. Then Inventor will show us the value of this tolerance. So it's very convenient when using Inventor. Okay. Okay, yeah, I think if I just want to use this one to tolerance, and then just click OK, and then I will move. Wait, let me move the position. Okay, so maybe the position like that. The diameter is 5.3, it's 7, and this is the lower tolerance. This is the upper tolerance. Okay. Okay, that's for the tolerance. Punch and bend, because this one is not for the sheet metal, so I don't need to put it like that. So if you want to create text, then you just use this one, text leader, for this particular position. Yeah. Okay. Or maybe if you want to create another symbols, like for example the geometric tolerance. For example, this one is for the datum. For example, this particular base here, okay, which is A. I'm using the A, yeah. Okay, A like this. Okay. We make it a little short. Okay, and then this one will be the feature. Okay, so for example, I want to make it this one is yeah. Okay, continue. This one should be perpendicular with the tolerance how much the datum will be the A, right? So this is the tolerance. Probably I want to make it 0.01 for the tolerance. Okay. Yeah, I can make it like a degree. So this one is the datum A. Wait, let me put it like that. Okay. Okay. Like this. So probably if I want to make like a symbol for the geometric tolerance, so Inventor also can provide us for us. Wait, I think this one should be not the thing here instead here. Yeah, like this. Okay. So this is the particular feature control for the tolerance thing. So if I want to make like the here, for example, the position here, you cannot miss. Okay, position here. Okay, yeah, this one, the position should be position 0.05. Okay, need to have a dash datum. Yeah, okay. So this one is the tolerance position for the hole here, 0.05. Okay. And then what else? I think this one is already explained it all. And also there's a whole table. We don't create a whole table here. Revision table and also the general. I think this one revision is not necessary for right now. Okay, so this is how you can create a part file, part drawing, and then after you create each of the individual part. Right now we have how much breadth, base here and pillar. You need to create more drawing, base atas as well as screw slider, handlebar, and also handlebar, and also the pipe I don't think is necessary. So usually, if there is a standard part like this, G's B117 1190, and also G's here. This is the hexagon nut and also the parallel pin. So all of the standard part usually is not necessary to create the part drawing. Okay. Then, so I think we finished for this tutorial here. So in here, in one file, we have what sheet 1 is the assembly, sheet 2 is the part drawing, and then you need to continue to the sheet 3, 4, and etc. to fulfill all those necessary part here, and then create all those parts. Okay. After that, if you want to export here, then you just go to here and then export and then go to the PDF file. So this one is basically creating the PDF file. So for example, this clamp AC, and then you have the option here if you want just to export one current sheet or all sheet or range from which sheet. Okay, and if you want to make it black, then they will check mark here. If you remove object line width is the the thickness of the line. Okay, so I don't think that you need to check mark here. Okay, then you just click OK here and then create a name and then save. Okay, so this one will create the PDF file, which is at the page 1. You are going to find the assembly drawing here, and then in the page 2, then you will find here, and then page 3, if you have another sheet, then they will create a multiple pages of the PDF file. Okay, so this one is show the result of the PDF. Okay, so this is the PDF file. In the PDF file, also you can see the layer here. So you still can turn on and turn off the layer here. For example, if I don't want to show the symbol, then you just click the eye here, eye icon. Okay, then they will hide the symbols, and this is the page one. And then when you scroll, then it's come to the page two. Page two, it's the same here. So the page two will be like this uh, at a particular file here. Then usually you need to make to create a name here. Okay, in order that for example, this one is one, number one. So this one, number one is base. Then you need to type key in here, the base. Okay, yeah, let me try to this one. If the default border, this is the ISO standard, then you can create the part number. Here, let me vision date. Which one is the type? One is the for the properties here. I properties, okay. Not the drawing properties. This one is the number of sheet. Okay, I think this one is the part number, and then they will read the part number to the wait, let me. Okay, so if you want to edit the what's called the title block here, for example, this one is actually they are using the name of this file name because this one is the drawing file name, then they will reflect to this one. So for example, in the sheet 2, if you want to make the name for this particular part that you insert, then you need to edit this particular definition. Just right click and edit definition, and then under this one, then you double click here. So you just delete first here, and then to the source, then you choose the attach model, which is the attach model, and the property that you want to put it inside. So for example, I want to put it the part number, and then add the parameter here. Then click OK. When you finish sketch and also save the ISO here, then they continue with this one. And then for example, if I want to create a new sheet here, and then let me see how's the ISO, the definition. Okay, this one is already attached, yeah, part number, yeah. Okay, so for example, if I want to create another part and then put it the base one, for example, I want to add the handlebar here. Okay, I put it the handlebar like that. Okay, and then click OK. So in here is automatically that they will type the part name of the part being inserted in here. So this is the advantage if you use the one particular sheet for one part. Okay, some of the company they use one sheet, just small sheet to create the drawing for each individual part. So they have multiple pages of the drawing. Okay. Okay, yeah, I think this video is long enough. It's almost half an hour. Then I think I should end this video, and then I hope this video have a big benefit for you, and you have learned something. And thank you for watching, and see you in the next video. Bye bye.